Hello everyone and welcome to Nested For Loops and Matrices. So you've already covered while loops and for loops, but now we're getting into really difficult territory. This video will be long, so make sure that you really pay attention to the concepts covered, and it will be difficult too. The first thing we're going to talk about are, of course, matrices. So what are matrices? Well, we've got to talk about dimensions first. Okay, so you may have heard about dimensions in school, right? 0D, 1D, 2D, and 3D. Maybe not 0D, so let's start from there. 0 dimensions basically means it's a spec. 1 point, 1 data value, that's it, right? Nothing more. 1D is a line. You may have heard this, right? It's a linear line, like a number line. It just has width. No height, no depth, just width. And usually this is represented with a list of data values, right? It's not just one data value, but a list of data values. But when you get to 2D, you can think of this as having width and height, right? And you can think of it as basically one red line being stacked on top of each other to form multiple lines. And each of these black faded out lines you see, you can think of them as one red line. And what does one red line represent? It represents a list of data values. And then of course there's 3D, which is basically a 2D object being repeated multiple times in the third dimension, right, which is depth. So we're only going to be covering in programming just 2 dimensions or 3 dimensions. 0D, which is one data value, 1D, which is a list of data values, and 2D, which is a list of lists of data values, right? Basically, you can think of this as we have a list, and each element in the list is not just one integer or one string or one boolean. It is a list of strings or booleans or integers, right? And so when is this applicable, right? Think about tic-tac-toe, right? You have a 3x3 grid. You need to represent that somehow. Think about Battleship, right? Think about these 2D grid games. Think about, any sort of game that's 2D. You need to work with the coordinates of the game. And so this is a fundamental concept you need to make sure you understand if you want to even go relatively forward into programming. Okay, so we're here and we're asked to find the average of a 1D list. This is just a quick little problem to get you thinking, right? So we're given a list of cars, and each car is represented by an integer, the cost of the car. Find the average cost of the cars in the list, right? And how do we find the average? Basically, it's the sum of the list divided by the length of the list. This is something you should be able to do. This is actually one of your problems in the problem set, so I recommend that you try to do it on your own, and we'll give you the answer later on in the video. But the reason why I wanted to talk about this is because let's look at its 2D variant, right? Instead of now being given a list of cars and each car representing one integer, we're given a list of cars and each car represents a list of tires, okay? Each tire is represented by an integer. Each car is represented by a list of tires. Of course, each car only has 4 tires. We're going to assume that, right? And we're trying to find the average cost of the tires in our data set. So here are the steps, right? We of course need to loop through the car list to get the sum, but for each car, we're also going to need to loop through the 4 tires in the car. That is the nested for loop part, right? And then the other interesting thing is that we're going to divide the total sum of the tire costs by 4 times the number of cars in the list. Why is it 4 times the number of cars in the list? Well, remember the average, we're trying to find the average of the tires, so we need to know how many tires are in the matrix, not how many cars. And so since we know that each car has 4 tires, we're just going to divide the total sum by 4 times the number of cars. And so we're going to see this in action here. The first scenario, here's the answer. Very simple, I'm not going to go over it. You should be able to read this and understand it. Now the 2D variant. Notice how the matrix is represented, right? It's a rectangle. A matrix cannot have one list have 4 and then another list can have 7. Each list has to have the same amount of data points. In this case, it's 4. It could be 5 or 6, but you can't have different sizes. You can, technically, right? But it wouldn't be called a matrix. It would be called some random blob of data, right? But usually data is like this, where you have like a 3x4 grid, a 4x5 grid, or something like this. In this case, we have 4 columns and 5 rows. Notice that it doesn't have to be a square, because in this case you have 5 cars, but each car has 4 tires, right? We could have 7 cars with 4 tires. Okay, next, notice how the nested for loop works right here. For car and car list, right? So that's our first loop. And then for each tire in that car, right? So we're going to loop through all 5 cars, and then for each tire in all those 5 cars, we're going to add that to the total sum, right? To get the total sum of all the tires. Then the total tires, of course, will have to be 4 times the length of the car list, because 4 tires per each car. Finally, we have the total sum divided by the total tires. Hopefully this will give you a better idea as to how you would loop through a board or a grid or a matrix, and how to even represent one, right? And so we are going to soon go over how to actually create a game with this idea of a matrix and a nested for loop. Okay, so here we are in our actual coding segment. So here's a scenario. We're asked to create a 2D board game. It should prompt the user if they want to convert a random row or a random column to all zeros. So basically the user can decide, do I want to just choose a random row to turn to zeros or a random column to turn to zeros? Or I can just simply quit the game. But if they don't want to quit, we're going to continue the game, meaning we're going to continue to ask them, do you want to turn a random column or a random row to all zeros, right? So this is going to use everything you've learned in the past 3 videos in order to, finish this game. So what is the first thing we're going to need to do? We know that we're going to have to create a 2D board, right? And we know that we're going to have to use the randit library. So let's go ahead and let's set up our game. Okay, so we've set up our game right? From random, import randit, because we know we're going to generate random stuff, so we need the randit function. And then we have our board. And now notice the board has 4 rows and 6 columns. Okay, 4 rows and 6 columns. We could have 6 rows and 4 columns. We could have 5 rows and 5 columns, right? We could make it a square. But to make this very clear to you guys, because we're going to go over a very new concept called index iteration, right? You've heard of the 1D version of index iteration, where we loop through each index of the list, right? And the reason we want to do that is to change an element within the list. We can't do that if we do 4 element in the list. We can't change that element. It won't change the list. We're going to have to use a for I in range length list type loop, right? Where I represents the index, and then we could say li, meaning that position at index I, equals something else. We can manipulate it and change it that way. Okay, cool. So we have a board. The board has 4 rows and 6 columns. What can we do from here? Well, we're going to need to create a while true loop. And why is that? Because remember, we're going to continue to play this game until they want to quit. So let's get this started. Okay, so the first thing I want to do is I want to set up my user choice, right? So I'm going to ask them, do you want to zerify a row, a column, or exit? Then I'm going to generate my random row and random column. Now this is very important, right? I'm going to generate both of these because I'm not sure which one they want, but there's no harm in generating both of them beforehand. We're going to use this later. But how do we generate it, okay? Notice that for the random row, we're generating it from 0 to the length of the board, right? What is the length of the board? The length of the board, this thing represents, so let me write this down. Len board represents number of rows, right? Because the length of the board is 1 row, 2 row, 3 row, 4 row. right? And so we can even make this even more clear by making a constant, right? Num rows equals length board. And the reason I'm making this all capitalized is because it's a constant. This is usually convention when you're never changing a variable. We're never going to change this variable. Now num columns is going to equal this thing, length of the 0th index of the board. Why is this? Well, think about it. This could be 1, this could be 2, this could be 3, this could be anything, right? Anything that's in the bounds of the list. If you go out of the list, we're going to get an error, of course. But the reason why I'm doing 0 is because, first of all, we know that our list is, our matrix is going to have at least one, row. Now, why are we getting the length of one of the rows? Because that's our number of columns, right? Because think about it. This is board 0, and we're getting the length of that. The length of this is 6, and we have 6 columns, right? So if you think about it, 1, 2, 3, 4, 5, 6, all of these are columns. And so that's why we do length of the first row, right? Num rows is the length of the entire board. So 1, 2, 3, 4 rows. But length of the first row will give you the number of columns. Try to wrap your head around that. If you've gotten that, everything comes easier. Let's look at how to actually turn rows and columns to 0. So if user choice equals R, okay, meaning that we want to randomly make a row all 0, we are going to need to loop through the column index, right? Because we're going to need to loop, like let's say we choose this row, random row, the second one. We're going to need to loop through 6, 7, 8, 9, 8, 7, and we're going to need to change them to 0. Now, can we use this loop? Can we say for element in board whatever, random row, right? Because we're choosing what row we want, right? For element in that. And then can we change the element to 0? Okay, remember, this cannot happen because you are converting element to 0, but element is just a temporary variable. It's actually not changing the board. If you want to change the board, you need the index of the place you want to change. But how do you get an index of a 2D list? How is that possible? Let's take a look. Okay, so let's take a look at this example, okay? So what I'm going to do is I'm going to use the shell to run our example.py. If you don't know how to do this, don't worry. Basically, I'm going to print out board, the first row of the board. And if you do this, we should get what we expect. 1, 2, 3, and 4. Now, this is a list. Can't we access the index of one of these items in this list? For example, let's say we access the 0th item. So we're basically saying, get the first row and get the first column of that first row, which is 1. So this should print out 1. Correct. What about if I do 2 here, right? So we're saying get the second index of the board. This is the second row, or the third row, right? But it's the second index. And then get the first column, which is 9. So this should print out 9. Correct. Now what about 0, 2, like that? This is saying get the first row, and then get the third column, which is 3, or the second index, right? Now what about if we do 2, 2? Try to figure this out yourself. This is basically saying get the third row and the third element of that row, which is 11. This should print out 11. Hopefully this gives you an idea of how to access a specific element in a 2D matrix. Okay, hopefully that segment gives you a better idea as to how to do index access, right? And so what we're going to do is we're going to do for column index in the number of columns, right? And honestly, I think I mixed these up, right? This should be num rows, but now it should be fine, right? For column index in range num columns, right? So we're going to loop through each column of one of these lists, right? And that random row, this is where the random row comes in. We're going to choose a random row from 0 to 4, right? Or 0 to 3. So mistake here is that if we do length board, we might generate 4, which will be out of bounds, right? So we have to do -1. That's a big problem. That's a big no-no. So again, let's replace this with that, and then this with that. Great. So random row, we're going to generate a random index from 0 to num rows minus 1, right? So we can generate a random row here. Let's say we generate this row. We're going to loop through each column index of that row, and then we're going to access the random row, and then that column index of that row. So let's say it's 7, right? And we're going to turn that to 0. Then the next one, turn this to 0. Then the next column index, next column index, next column index, next column index. We're done. We're going to print out the board. Okay, hopefully that makes sense. Try to think about it. Okay, if you go to the column, this time, this will probably make more sense after you've understood the first part. Here, we're going to go through the row index, right? We're going to loop through each of the rows, right? But our column is set. Our random column can be from anywhere from, in this case, how many columns do we have? 6. So 0 to 5. Our index can be anywhere from 0 to 5. It could be this column. It could be this column, right? I can't highlight downwards, but hopefully you're getting what I'm saying. It could be this column. So let's say we choose the second column, right? We're going to go down the row. So 2, 7, 6, 1, we're done. That's what this is doing, right? We're looping through the row index based on the number of rows we have, and we're going to access that area and turn that to 0 and print the board. And then our final two things is very simple, actually. So let's look at what those are. So if they say E, we're simply going to break out of the while loop. This should be obvious. If they want to exit, we break out of the while loop, the program ends. But if they say something that's random, then we're going to say invalid choice, and we are going to continue the loop. So let's see if this works. So let's actually move this up here. Right, so do you want to zerify a row, a column, or exit? So let's try exit first, actually. Good, we've exited. Now let's try something random. Good, it works. And as you can see, the while loop continues. What about if I do row? We should probably be printing this out better, but it works. It randomly zerifies a row. Now let's try a column this time. This is harder to see, but if you notice, it has zerified the 5th column, right? In this case, this is already 0, so that's fine. This is also 0, this is also 0, and this is also 0. So it has, in fact, zerified the 5th column, right? We can do it one more time. This time it has zerified the 6th column, and then let's exit. A very dumb game, I'd say. Like no one would really play this, but this gives you a good idea as to how you can make your own mini games, right? This, if you want to make a battleship game or a tic-tac-toe game, it's going to be way more complicated than this. But trust me, if you understand the basic concepts of how to loop through a matrix, you are going to have such a fun time working with a whole bunch of games like tic-tac-toe, Connect 4, any 2D grid type of game you want to work with. You can work with it as long as you master this concept of index iteration, matrix creation, and nested for loops talked in the previous video. Thank you for watching, and I will see you in the future. This time, you'll